Hi guys, welcome back to our lesson. So we are still looking at the concept of whether functions, or rather inverses, are actually functions, right? Just remember that for us to talk about a function, it needs to adhere to a one-to-one or a many-to-one. But we realize that when it's a many-to-one, the inverse will not be a function unless you restrict it. So now what we are going to do is to apply all of this to questions now, to try and see exactly how do we apply this whole concept of an inverse. And these questions are questions that are adapted from past papers that we have out there. So just please follow me here. Wherever you do not understand, you know you always have the right to go and investigate it, please. So let's have a look at the very first question. So the first question says the following equations are given, and the equations are f of x is equals to a log. Immediately I say this, I'm already thinking the inverse will be the exponential graph, right? Already I'm thinking about that the inverse of this will be the exponential graph. And then g of x will be the hyperbolic function. So now we need to sketch this, but before we do that, they tell us, excuse me, that we need to label our intercept with the x's. So to do that, we first need to find the intercept, right? So I will say here I want the x-intercept, x-int, meaning y is equal to 0. So you can see this will be 0 is equals to log of x base 3, and then this will be x is equals to 3 to the exponent of 0, and then x will be equals to 1. So in simple terms, this will be 1 and 0, all right? And then what do we know? We know that for the y-intercept, it means that our x needs to be 0, and this cannot happen, right? So we can't have this x as a 0 because there's no base and exponent that will give me a number that is 0. So this is undefined, right? So already I know this is one important point. And if this is undefined, it simply means that this is the asymptote of the graph, right? And the asymptote of the graph will then be x is equal to 0, right? So meaning it does not cross on the y-axis. Now with this hyperbolic function here, I will also find firstly the y-intercept, meaning my x-intercept, therefore my y equal to 0. So this will be 0 is equals to 1 over x minus 1. You can see I will need to cross multiply, so this is simply no solution or undefined, right? But the y-intercept will then be x is equal to 0, which will simply be y is equals to minus 1, because it's going to be 1 over 0 minus 1, you see. So what does this tell us? It tells us that this one here is our asymptote, right, which is the y asymptote, and that is y is equals to 0, right? And then our x asymptote will be x is equals to positive 1. Now, to go about drawing this, this is what you're going to have, right? So the first thing to do, remember, is always to firstly draw your asymptote, which I wanted to show you how to go about drawing it, and then you label it x is equals to 1, right? And then the y asymptote is just y equal to 0. You don't need to show that because it's on the y-axis, it's on the x-axis. And then for the exponential, just remember, or the logarithmic function, x cannot be 0, meaning it must be, x must always be greater than 0, because it cannot be 0 since it is the asymptote. So it can only be on the right-hand side. Hence, you can see my arm is just there. It does not cross to that side, or it does not cross on the y-axis, although my line seems, or my curve seems to be crossing. Now, determine the equation of the inverse of g firstly, right? What is our g? G is the hyperbolic function. So our inverse will still be the hyperbolic function, right? So remember, what you need to do here is to interchange these things. So it will be x is equals to 1 over y minus 1, and then this will be the same as y minus 1 equals to 1 over x, and then y will be equals to 1 over x plus 1, right? So already this will be my equation. And let's just quickly see, they did not specify which form, and they just said y is equal. So you can leave it as y equals to, or you can leave it as g to the minus 1 x is equals to. And then determine the equation of the inverse now of f. F is a log, right? Just remember, if it's a log, it means the inverse will be the exponential graph, right? So to do that, still, you interchange the values. So this becomes x is equals to log of y base 3. By the way, guys, for those that are wondering where I'm taking these formulas from, let's just quickly go here. I'm just simply talking about that formula there, right? So that's where it comes from, just so that I don't confuse people and you think I've introduced a new formula. And then just remember to always label this. Guys, I promise you, it will really serve you a great purpose if you do. So this is normally our exponent. We know this is our base. We know this is our number, right? So in simple terms, this will just be our number, which will be y is equals to, and then our base, which is 3, and then our exponent, which is y, is x. And then this will be the inverse function. So with these two things that we've looked at, just remember the main thing here is to always interchange. By the way, there is a mark for you to do that. Firstly, interchange them. I mark that because that means you understand what an inverse is. Your simplification, there's a mark for that. And then your answer, there's a mark. So at times you get 2 marks for the swapping and the final answer, or 3 marks for the swapping of the interchanging of the variables, the simplifying or your method, and then lastly for the final answer. So it's an either or. It depends on how much work you need to do there. So please remember, you start by interchanging them. I am not just doing it so that I remind you. No, it's because you need to do it so that it is clear on what you are trying to do after that. And then we are required to now sketch these graphs, right? And these graphs are the inverse functions. So quickly, just to show you this, I'm now going to take the concept of the intercepts to try and talk about this. Why am I saying the intercepts, right? Remember that we said x cannot be 0 because it gives us an error, right? So it means for the inverse, this is going to be error and 0, right? Because you swap them around. And then this one is 1 and 0, so it means for the inverse, it will be 0 and 1. Right? And then lastly, the asymptote here, remember we said it was x equal to 0. It means the asymptote here will be y equal to 0. So how you draw this graph, excuse me, remember the original function was that one there where it was intersecting at 1 there. This will also intersect at 1 on the x-axis because you're going to swap them around. Oh, the original was this one, I mean. The dotted line one, and then the blue one is actually the origin, the inverse function. So let me just erase this so you can see exactly what I'm talking about, right? So I'm just doing them individually so you can see, and then at the end, it will be both of them in one plane. And then the second one was this one here, right, which is g of x and the inverse. our y asymptote was 0 and minus 1, so it will be minus 1 and 0. And then our x-intercept was error and 0, so it is going to be 0 and error, 0 and error, right, because x cannot be there. And then our asymptote here was y equal to 0 and x is equals to 1. And then our asymptote here will be y or x first is equals to 0 and then y is equals to 1, right? And then quickly on the Cartesian plane, it will look like this, right? So firstly, remember it was 0 and minus 1, which was somewhere there. And then it was 0 and minus 1, which was down there, and then it was the asymptotes that we had, which was y is equals to 0, meaning y is equals to 0 will be on the x-axis, and then x is equals to 1 will just be simply there, right? There. So the dotted line will be the original, and then the purple one will be the not the asymptote, the inverse function. And then if you draw both of them, then this is how these two graphs are then going to look. The only thing you just need to make sure that you are aware of is how to switch the things around so that it makes sense on what exactly you need to do. Guys, I hope you are enjoying this and you are seeing how this can be asked in context now, right? Because we've been talking about general terms. This is what an inverse is. This is what a function is. Now we are looking at the actual questions just to see how to actually talk about these functions. But for now, I want to take a quick ad break. When I come back, I will then look at one more question that we're going to look at that is adapted from the past papers. Please stay tuned. I'll be back just now.